So we're going to be talking about positive exponents and the laws of exponents. Normally when you take a look at the notation here, you'll see that we have a to the n. Now that a is often referred to as the base, and the n is often referred to as the exponent. So we can read it as the nth power of a or a to the power of n, which I generally prefer. If we take a look at the example over here, 8 to the third, so that means our base is going to be 8, and our exponent, here's the number 3 again, which is going to tell us that we have 8 multiplied together 3 times. Remember that an exponent is just a form of notation that tells us how many times that base is being multiplied together. So what we're going to do now is a little exploration to take a look at some of the laws of exponents. So the first thing I'm going to do is take a look at 7 to the second times 7 to the third. What that really means is that I have 7 times 7 times 7 times 7 times 7 times 7. I think I said too many sevens. In any case, we have 7 times 7 times 7 times 7 times 7. So we have 5 7s being multiplied together. So our notation here is 7 to the 5th. Then in our next example, we have 2 to the third times 2 to the 5th. So we have 2 times 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 2. So in this case, in terms of our exponential notation, we are going to have 2 to the 8th. So what you can see here is some sort of pattern that is starting to emerge. I probably don't need to write out a to the 4th times a to the 3rd, because I can see that that will be a to the 7th, which means really what I'm doing is whenever you have similar bases and you're multiplying similar bases with different exponents being multiplied together, what's really happening is that you're adding the exponents together. So there's your first law. Now let's take a look at division. So here I'm dividing 5 to the 6th by 5 to the 2nd. Now again, if I look at that, I see that I have 5 times 5 times 5 times 5 times 5 times 5 divided by 5 times 5. Now if we simplify by eliminating common values here, we see 5's cancel out there, 5's cancel out there, and what we're left with is a result of 5 to the 4th. Taking a look at the next example, 8 to the 7th divided by 8 to the 4th. Again, if I write that out and start crossing out values here, we see some sort of pattern start to emerge, hopefully. So by the time that we get to other values here, we can see, for example, that c to the 5th divided by c to the 3rd is going to be c to the 2nd, and that brings us to our next law, which is whenever you are dividing similar bases with different exponents, what you end up doing is subtracting the second exponent from the first. Now remember, this is only working if the bases are similar. If they're not, there are some other things you can do to help. Now let's take a look at a third law. There are a couple more, don't worry. So we have 9 to the 2nd to the 3rd. So now we have a power raised to another power. So that means we would have, in this instance, 9 to the 2nd times 9 to the 2nd times 9 to the 2nd. Now if you remember from before, that means we have 9 times 9 times 9 times 9 times 9 times 9. So that's going to get us 9 to the 6th. Also, if we take 3 to the 5th to the 4th, so again we're raising a power to a power, we're going to have 3 to the 5th times 3 to the 5th times 3 to the 5th times 3 to the 5th, which is 3 times 3 times, okay, I'm not going to go all that way, but what you will see is you end up with 3 to the 20th. Then over here you're going to end up with x to the 10th. So hopefully, see, when we have a power raised to another power, then all of a sudden what happens is we're actually multiplying powers together. So you have a to the m to the n equals a to the mn. It's a pretty fancy way of saying that. Now, one more rule for now. This time it involves fractions. Now, fractions actually follow the similar laws that we've been talking about before. In this case, I have 2/3 to the second, which really means I have 2 times 2 over 3 times 3, or 2 to the second over 3 to the second. Same thing with 7 over k. Oh, I don't know why that says 3. Let's erase that. Clearly I was thinking of something else. And then we have 7 to the third over k to the third. So then finally what rule we have here is anytime you have a fraction raised to a power, as long as that power does not equal 0, which we will get to in a different discussion, and as long as that b does not equal 0, again, we'll get to in a different discussion. But anyway, when you have a over b raised to a power, that means both your numerator and your denominator are raised to that power. So here are the main laws of exponents that we're covering today. Again, we have our first one where you add exponents together when multiplying. When dividing similar bases, you subtract. And when you have a power raised to a power, you multiply the values together. And then when you have a fractional exponent, that means both the numerator and the denominator will take that exponent. So why don't we go ahead and try some of this out? What you can certainly do now is pause the video, work these problems out on your own, and then watch me solve the problems to see how you did. So our first example is a to the 5th times a to the 7th. Well, this is very similar to a to the m times a to the n, which means we're going to add our exponents together, so we're going to get a to the 12th. Then in our next example, we have p to the 13th divided by p to the 7th. So again, this looks like a to the m divided by a to the n, which means we subtract our exponents. So we're going to get p to the 13 minus 7 equals p to the 6th. Now, the last one gets a little tricky, but the first thing we need to do is take a look at our coefficients. We have 3 and 4. Now these coefficients, remember, they're just numerical values, so you do that multiplication first. You have 3 times 4, and that equals 12. Now we're going to look at similar exponents, similar bases. We have p to the 2nd times p to the 6th. So that is p to the 2 plus 6, which is 8. Remember, we're not raising a power to a power. And then we have q times q to the 8th. So that is 1 plus 8, which is 9. So our answer is 12, p to the 8th, q to the 9th. Now that might be a little tricky, and that's all right. We'll be working on more of this in class. But before we do, I have a challenge problem for you. Oh yeah. So we have 3a to the 5th over b to the 3rd, all in parentheses, raised to the 4th, divided by negative 9a to the 3rd over b to the 6th, all in parentheses, raised to the 2nd. It is a challenging problem. It is going to take some time. One hint to you is to remember that this exponent right here does affect your coefficient. That's an awesome hint. Anyway, go ahead, give it a try, and we'll see how it goes.